Guys, have you ever asked Siri or Alexa to set a reminder for your meeting or tell you a joke? Or might have used Google Translate to communicate with a friend who speaks French? But do you know that someone has to teach these chatbots or robots that how to talk like a human? Guys, that's where natural language processing, that is NLP, comes in. Today in this video, we will see all about what is NLP, what is its need, some real-time applications, common NLP tasks. Then we will see approaches for NLP, what are some challenges faced in NLP, NLP pipelines, and at last, a project based on it. So let's get started with introducing NLP. Guys, NLP is just like teaching a computer or machine how to understand what we say and how to talk back to us, just like we talk to our friends and family. It's a part of computer science, human language, and artificial intelligence used by machines to understand, analyze, manipulate, and interpret human languages. So, in simple words, NLP is nothing but giving the computer superpowers to talk like a human. Now, what do you think? Why we need to learn NLP? Guys, NLP is like a bridge that connects people and technology. Do you know? Most of the information on internet is in the form of text. Say we want to analyze if the sentiment is positive or negative on our tweets, or an e-commerce company wants to analyze customers' feedback. But we humans don't have that much time to sit and analyze all the tweets or feedbacks one by one. And here comes NLP. Guys, we can automate the analysis of text data, which helps us uncover insights that are difficult to find manually. Apart from text, NLP is also used to process audio and video data. Like automatic captions for videos on YouTube are generated using NLP. Or we can also analyze reviews of podcasts using NLP. Now, NLP comes with many applications because it's like a secret language that you and your tech devices can understand. You can talk to chatbots like ChatGPT, which can help you with everything from shopping to troubleshooting tech problems. Virtual assistants like Siri and Alexa, these are like your personal assistants that can do everything from setting reminders to playing your favorite song. NLP helps you improve your writing with the tools like Grammarly, and using sentiment analysis you can understand how people feel about the products on e-commerce. How cool is that? So, what do you think? What kind of tasks can be performed by NLP? Guys, we can perform tasks like text classification, sentiment analysis, language detection, and machine translation. NLP tools makes it easier to sort and organize large amount of data, analyze people's emotions and attitude towards the product, and detect the language of a text. So guys, whatever we have achieved in NLP is done by using mainly three techniques, which are heuristic methods, machine learning based methods, and deep learning based methods. NLP started in around 1940s. Till 90s means for around 40 years, heuristic methods were used. These methods rely on rule-based approaches or handcrafted rules and patterns to extract information from text data. Then the era of machine learning started from 90s. It uses statistical algorithms to learn patterns and relationships in the text data. And deep learning era started in around 2010, which uses neural networks and large amount of unlabeled data to train models. All these are even used today and have different impacts. Now, we will see some challenges faced in NLP. Guys, there are some weird parts in natural language, like contextual word slang, synonyms, irony, sarcasm, spelling errors, diversity in languages. These are some challenges in NLP, as these are easy to understand by humans but not by machines. Next, we are going to see NLP pipeline. So, what exactly are pipelines? A pipeline refers to the sequence of steps applied to raw text data to transform it in a form that can be understood by machines. In this pipeline, first the raw text data is segmented into smaller chunks or segments called segmentation. Then each segment is broken down into individual tokens or words, and the process is called tokenization. Then we do stemming, in which each tokens are reduced to their root form by removing suffixes and prefixes. For example, caring would be reduced to car. Or we can do lemmatization, where the tokens are reduced to their base form using a dictionary and the part of speech is preserved. For example, the word caring would return care. Each token is identified and labeled as parts of speech, in short POS, like noun, verb, adjective, adverb. These are called tagging. Or the entities in the text data are identified and labeled, such as people, places, organizations, and dates, known as named entity recognition, in short NER. The final file we get can be easily understood by user, called parsed data. So now that we have understood pipeline of NLP, finally it's time to apply these learnings practically. Guys, we all know that recruiters receive large number of resumes for a single job opening, and it's very time consuming for them to go through each and every resume manually and shortlist the most relevant candidates. This process not only takes up a lot of time but also can lead to human errors, as only 7 seconds on an average are spent on one resume. So these days, recruiters use tools like ATS, which is an application of NLP only. So the goal of our project is to extract relevant information from a resume and compare it with the job description. By doing this, we can calculate the similarity between resume and job description and can automate the process of shortlisting most relevant candidates, which will save time and reduce human error. However, there are some difficulties that we may face while matching the resume with the job description. The first challenge is quality of the resume, and the another challenge is the variation in job description. Like different companies may use different terminologies and job titles for the same job. So guys, without any further delay, let's get started with the project. So guys, in this project, basically we are going to use Google Colab. Right, it's a collaboratory that allows anybody to write and execute Python code through this browser. Okay, so basically we don't have to take tension or take headache of installing and downloading any extra applications or IDEs like Visual Code Studio or Spider or Anaconda, anything like that. Okay, so to start with it, we will go to this file option and we will create a Jupyter like new notebook here. And guys, we will name this notebook as, let's say, resume screening project. So the first step to start anything, first we have to import the dataset, right? So we will go to this files option, and here we can see this upload button, right? Upload to session storage. We'll click on this, and guys, these are the files we are going to use. It consists of like almost 7 to 8 resumes. Some are in PDF format, as you can see, and some are in docx format. Along with it, we also have this job description file. So we will simply select all these resumes and job description also, and click on this open button, which will load all these files. So guys, basically we can see this warning appearing on our screen. It says that all the files should be saved somewhere else also, because these files will be deleted once we terminate this, right? So okay, fine, we will just click on this OK, and we can see we have our files or our data loaded here, right? So to start this project, or before starting this project, let's just have a look at all these resumes or job description we are having. So let's see. So guys, here you can see like all the resumes or job description, almost all are in PDF format, right? But we have also kept a Word file here. This is because it's not like necessary that all the resumes or all the files should be in PDF format only. Sometimes it can be in Word format, like docx format or doc format, anything it can be. So just first we will see the job description. So we are, as of now, we are using this data scientist job description, right? So just have a look at this description. So guys, as we can see, this is the job description for data scientist position, right? And there are several sections like description, then we have responsibilities, okay, then we have experience and minimum qualifications. So here we can see like it requires solid knowledge of statistical methods and machine learning fundamentals. Then you should know Python or R, and strong proficiency in SQL. Then you should know Pandas, NumPy, scikit-learn, all these, right? So we have then Tableau, Power BI. So this is kind of job description for data scientist position. So guys, as you can see, we are having job description for data scientist position, and we have taken resumes of several positions like senior data scientist, then NLP data scientist, metadata data scientist, entry level data scientist, then we have manager level, analytics or associate data scientist. So guys, this is also the resume for data scientist position, but it's in Word format, right? Not in PDF format. So let's have a look at this. So as you can see, this is the resume for Shrishti Sinha, and she is an aspiring data scientist. So as we know, resumes are in this format only. Like first we write objective, then qualifications, then we have skills and certifications, projects she has done. So it looks quite cool. Like okay, she knows Python, R, Tableau, SQL, machine learning. And if we match this resume with job description, so yeah, some of the skills are matching here, right? And also we can see like what experience she is having, or what all the projects she has done, all these things, right? So let's move on to next resume. Say senior data scientist resume. So how does it looks like? Fine. So he has provided his LinkedIn ID, then again work experience and education skills, all these things are here. So fine, we have seen job description and some sample resumes, right? So guys, after loading this data into Google Colab, the next step is to import the dependencies, right? But before importing the dependencies, we have to install them in our system, the system in which we are making this project, right? So to install the dependencies, we will use pip command, exclamation and pip command. Then we will write install and the name of library or package we want to install. So as of now, for this particular project, we are installing these three libraries: pypdf2, docx2txt and NLTK, right? So let's understand all these libraries one by one. The first library is pypdf2. Guys, this library is used to extract text data or metadata from PDF files, right? Then next is docx2txt. This library is used to extract text data from docx file. And the last library is NLTK, which stands for Natural Language Toolkit, right? So guys, basically this is a natural language processing library which is used to perform some tasks like text classification, tokenization and stemming. So maybe if this is your first NLP project, then these libraries can seem to be somewhat difficult or new to you. But no worries, later in this session we will understand all these things one by one very clearly, right? So let's now import these libraries. So these are some libraries which we need to import for our particular project. The first one is this import PyPDF2. We have already seen what is the use of this. This is used to handle PDF files. Then the second one, docx to txt, this is used to handle docx files, right? Then we have imported this file, right? So we have installed these three libraries first, and we have also imported these libraries. So let's now understand all these libraries which we are importing. So the first one is stop words. Guys, stop words are nothing but a list of commonly used words like I, me, you, like these, which can be ignored from processing text data, right? So we are importing this stop words from NLTK library. Then the second one is word tokenize, which is used to basically split text into individual words, or we can also say tokens. So again we are going to import this from NLTK library only. Then the next one is matplotlib.pyplot. So basically we are importing this library from this matplotlib, right? This is used to draw plots in Python. Then the last one we are having is word cloud. Okay, so we will see all these libraries, how to use them and where to use them. Okay, so these are the commands to install the libraries or dependencies, we can say, and then we can import the dependencies. So let's now run this cell. So we can use shift plus enter to run any cell in this. Guys, it might take some time to load the libraries, right? Because whenever you are installing these libraries for the first time, you have to keep some patience because it will take some time. Okay, so we can see our libraries, all the libraries are installed. Now we can import them. So fine, we have run all these cells successfully. So now after installing and importing these libraries or dependencies, the next task we have to do is we have to convert the PDF file, or we have to extract the text from PDF and Word files. And for that we will create two functions. First is to extract text from PDF, and second function will extract text from Word files, right? So guys, to convert text from PDF file we have this function. Now let's understand this one line by line. So this is def, and this is the keyword to define any function in Python. Then this is the name of that function, and it can be anything, right? You can give it as per your requirement. So now my requirement was like to extract text from PDF, and for that reason we are naming it extract text from PDF. So inside this parenthesis we will give argument. So now we will give argument as file path, right? And at last we will return the text extracted from that PDF, right? So basically this function will take input as PDF and return the text extracted from that PDF. And this is the central. So let's understand it line by line. So the first line is open and this file in read mode. So basically this is this open function. What does it do? This will open any file given in, and here we can write the mode in which we want to open the file. So as of now we are opening this file in read mode, that is to in read binary mode, right? So guys, these are all the basics, like how to open a file, how to close a file, right? Then how to open it in read mode or how to open it in write mode. These all are the basics of file handling which you should know before starting this project, right? So this first line, I hope you are clear with it. We are just creating a variable which in which we are storing this open file in read mode. Then the next variable we are creating is PDF reader, which is equal to this. Basically this is the module PyPDF2 which we have already imported, and this PDF reader is the function of this module. So what is the role of this function? Basically it is used to create a reader object for the open PDF file. So it will do nothing, but it will just create an object for this open file, right? Now next is nothing but we are just storing an empty string into this text variable. Fine. Guys, this for loop iterates through every page, through each and every page of the PDF. And for each page, its text is extracted using this extract text function. As you can see here, this is the extract text function, and it will extract the text from each and every page one by one. So how one by one? For that reason we are using for loop, right? So for page in range of length of this, so basically this alien, these are all the basic functions like length, how to calculate the length of any PDF. So for that we are having this function len, and to iterate through every page we are using this for loop in range of this length. So I hope you are clear with this, like how to use for loop. And this extracted text is appended to this text variable which we have created. So as of now you can see this text is an empty string, but on the spot we extract this text from each and every page. Let's say we are on page 1, right? So what this loop will do, this will extract the text from that page and it will store that text into this text variable which we have created. So now this text is not empty, but it consists of all the text which is extracted from page 1 of that PDF. I hope you are very clear with it. And guys, this is the most important part of this complete function, like how to extract text from PDF. So through every page we are iterating and we are storing that text into this text variable. So fine. Now at last we will just close this file. We have opened this file, so it's necessary to close this file, and then we are returning this text. So let's just run this complete function and see the result. So we can see this function is completely executed and successfully executed, right? But we cannot see any output here. We have returned the text from that file which we have provided, but we cannot see any output. Guys, the reason for that is, in Python, functions are executed only when they are called, and now we haven't called this function anywhere, right? And like this only we will create all the functions for particular task we are going to do, and at last we will create a main function in which we will be calling all these functions, right? So as of now we are just creating the functions. Remember, we are just creating the functions, we are not calling them. So okay, fine, this is the function we have created to extract text from PDF. And in a similar manner, we will create another function to extract text from Word files, right? So guys, this is the function to extract text from Word file, and obviously it seems more easier than this one, right? So this was a very long function and this is just a one-line function. So in first line we are just creating this function, we are just defining this function, again def and name of that function, and again we will give argument as file or Word file as of now. So inside this text variable, basically what we are going to store, so docx2txt, this is the library we have already imported, right? And this process is the function of this library. So this basically, what does this do? This will convert that docx file to text, or it will extract the text from that docx file, right? And this function will return that text. So basically these are the two functions we have created to extract text from any kind of file. Now just keep one thing in mind, guys. It's not necessary that we have all the documents either in PDF only or in Word only. There can be other formats also like doc, right? So we have to create a different function for that. But we see most of the resumes we get, or most of the job descriptions we get, are in these two formats only. So for that reason we are creating these two functions only. So I hope you are very clear with how to create these functions and how to return the text extracted from these two kinds of files. So guys, next we need to pre-process the data, right? Pre-processing the data is very important, right? And here we will pre-process it by removing the stop words, removing punctuations, and we will convert all the words into lower cases. This is the function to pre-process the text data which we are getting from these extracted files, right? So guys, let's understand this function line by line. This is the def, again how to define a function. this is the keyword to define a function, then this is the name of function. For now we are using preprocess text. So this function will pre-process the text whichever we are providing as an argument, right? And it will return the filtered tokens. This is the variable. So now let's see how this variable came. So these are the three main lines, or whatever we write inside def, this center part, this is the most important part, and this is actually what this function is going to do, right? This function will first load the set of stop words of English language, right? So we are just using this stop words, dot words and English. So what it will do, just copy this and try to run this, and let's see what it results. And guys, as we can see, these are some stop words in English. So stop words are nothing but some common words which can be ignored easily in any text, or these are not some useful words. It won't make any sense or any meaning in the project we are going to do, like I, me, my, myself. These are some very common words which can be ignored, right? Next guys, this input text which we are getting from argument, so we are passing this and we are applying a lower function. So what it will do, it will convert all the text part, all the text in lowercase, right? And all the text which is converted in lowercase is passed to this word tokenize. Now what is this? This function tokenizes the individual words, right? Tokenizes means let's say there is a line or there is a paragraph and we want to extract each and every word of that paragraph. So tokenize means creating tokens. Tokens are nothing but the smallest or individual units of anything, any paragraph, any line, anything, right? So basically we are first converting a text into lowercase and then we are sending it for tokenization. And this last line is basically, this is a for loop, right? Now guys, what does this last line is doing? This is basically a for loop, and this for loop iterates through each and every word in the tokenized list of words, and it filters out any words that are not alphabetic, right? So suppose we are having some special characters or some numeric values inside our files. Files are basically either job description file or resume file. So whatever the special characters or numeric words we are having, it will filter out those words and it will keep this word dot is alpha, will keep only those words which are alphabetic in nature, right? And this means the words that are not in stop words, only those words will be filtered out. And guys, this is the for loop, word for word in word tokens. It simply means that we want only those words from these tokens which are either alphabetic in nature and which shouldn't be in that stop words list which we have seen right now. So it's very easy to pre-process the text data, and guys, finally this function will return the filtered tokens to us. So right now we have just seen three functions. First is to extract text from PDF, then we have extracted text from Word file, and finally we will run this function that is to pre-process the text we have extracted from both the files, right? So let's run this, and yes, it is executed successfully. So now guys, that we have extracted and pre-processed the text data, it's time to compare the job description and the resume, and for that we will use similarity score. And to find that similarity score between two text files, that is job description and resume, we will use Cosine Similarity method. Cosine similarity is nothing but a metric that is used to measure the similarity of two vectors, right? Now, how we are going to calculate those two vectors? Again comes a very important statistical measure. Mind my words guys, this is the most important part of this complete project which I am going to tell, that is TFIDF. It stands for, TF stands for term frequency and IDF stands for inverse document frequency, right? It is a statistical measure that is used in natural language processing, NLP, which is used to evaluate the importance of a word in a document or corpus of documents, or we can say collection of documents, right? So let me explain you this in very simpler words. If we explain it in simpler words, it's like it helps us to identify which words are most relevant to a given piece of text, right? The idea is that a word that appears frequently in a document but infrequently in a corpus is more important or informative as compared to a word that appears frequently in both. I know guys, it sounds like very confusing. No worries at all, we will explain this using a very interesting example. But first, let's understand the meaning of terms TF and IDF. So TF means term frequency. It's a measure of frequency or a term in any document, right? And what is the formula for this? Guys, it is calculated as the number of time a term appears in a document divided by the total number of terms in that document, right? And the next is IDF, that is inverse document frequency, and it is the measure of rarity of a term in a corpus. Again, corpus is nothing but collection of multiple documents or many documents, we can say. And guys, how it is calculated? So the formula for that is logarithm of total number of documents in the corpus divided by the number of documents in which the term appears, right? So we will calculate it, we will understand these things using an example. So in total, TF-IDF is nothing but the multiplication of both these terms, that is TF multiplied by IDF is equals to TF-IDF. It's that simple. Now, before understanding this term or this statistical measure with an example, first note one thing, that this TF-IDF score is higher for the terms that appears frequently in a document but rarely as a whole in a corpus, right? So just mind this thing. So guys, it's now time to understand this typical term with a very interesting example. So let's say we have two job descriptions. One is for software engineer and one is for a data analyst, right? And we want to compare the job description to see how similar they are in terms of their content. And to do this, we will use TF-IDF. So for example, let's look at the word programming, right? So in software engineer job description, the word programming appears 5 times out of 100 times. So what will be the term frequency, or we can say TF? That is 5 divided by 100, which will be equal to 0.05, right? And in data analyst job description, let's see the word programming appears 2 times out of 80 times. So this time what will be my term frequency? It is equals to 2 divided by 80, that is 0.025, right? So we have calculated TF for both the things. Now it's time to calculate IDF, that is inverse document frequency. So if we assume there are 1000 job descriptions in total, like including for data analyst and for software engineers, right? So guys, this programming appears in, let's say, 200 out of them. So out of 1000 we are having programming word in 200 of them, right? What will be the IDF for this? So it will be log of 1000 divided by 200, and that will be equal to, we can calculate it, right? And that is equal to 0.698. Now as I have already told you, TF-IDF, this complete term is equal to TF multiplied by IDF, right? So when we calculate TF-IDF score for programming in both the job descriptions, let's first calculate for software engineer. So it is equal to 0.05 multiplied by 0.698, and it will result into 0.035, right? And if we will calculate this thing for data analyst, then it is equals to 0.025 multiplied by 0.698, and the result for this is 0.017, right? So guys, what does it tell us? This tells us that programming is more important in software engineer description than that in data analyst job description, because the TF-IDF score for programming is higher for software engineer role, because it is 0.035, which is obviously greater than 0.017. And this is what we have observed. And guys, we can repeat this process for all the words in both the job descriptions, as now we have done this thing for programming word. Similarly, we can do it for all the words we have extracted, right? We have preprocessed, right? So this was all about TF-IDF, how to calculate this. And now we will write a function to calculate the cosine similarity, or we can say the similarity in job description and resume. And guys, this is the function. So right now we have discussed TF-IDF and cosine similarity, but to use them, first we will have to import them. So how to import them? So guys, first one is this TF-IDF vectorizer. So how we will import this? We will import this using this scikit-learn library, right? And inside that feature extraction text part, we will import this TF-IDF vectorizer. Similarly, to import this cosine similarity, we will use scikit-learn library matrix pairwise, right? So these are the two libraries we can import. So now let's understand this function to calculate the similarity. So basically, what similarity we are looking for? We are looking for the similarity between resume text and JD text. So these are two arguments, that is the text part extracted from resume and the text part extracted from JD, that is job description. And this is again the name of this function to calculate the similarity, right? And we are at last what we are returning? We are returning the similarity score. So let's understand these lines first. So basically, first one is vectorizer, and this is the object of this TF-IDF vectorizer, right? So now these are the two important lines which we have to understand. Guys, this fit transform method of the vectorizer object is used to calculate TF-IDF vectors for the resume and JD, right? And this returns a sparse matrix of size 2 cross n, where this n is the number of unique words, right? So like this, we are having two text files, one is this and one is this. So when we will have n number of unique words for both the files, so the final matrix which we will get is of dimension 2 cross n, right? And guys, this cosine similarity function is used to calculate the cosine similarity score between both the vectors we are getting from here, right? Guys, this vectorizer function is giving us nothing but a 2 cross n matrix, that is a matrix of vectors obviously, and this we are passing these vectors in this cosine similarity, so it will give us a similarity score, right? And guys, this is how finally this function will return the calculated similarity score as output. This was a very important function. I hope you have understood it very clearly. So guys, next what we are going to do is we are going to create a function to draw a word cloud. So word cloud is nothing but it's kind of a visualization where we can see the frequency of all the words, like a word is appearing how much times in that particular document, right? So more the number of times a word is repeated in any particular document, the larger will be the size of that word in word cloud, right? So we will understand this. So first let's run this, and guys, we will understand this when we will run the main function, right? So guys, finally we will call all these functions and compare the resume and the job description, right? So we are making a main function here, and remember guys, inside this main function only we will be calling all the functions we have created till now, like this word cloud for creating a word cloud. This is the calculate similarity function which calculates the similarity between job description and resume. Then this is the preprocess text function which will preprocess the text we are extracting from these two files. And guys, these are the two functions to extract the text from docx file and from the PDF file. So these all are the functions which we will be calling inside this main function only. So guys, that was the reason I was saying when we are executing these functions, when we are running these cells, we are not getting any output because we haven't called these functions. We have just created those functions, but it's time now to call these functions inside this main function. Before that, let's just understand this main function. What does it says? So guys, first we are setting the file path for job seeker's resume and job description. So as you can see, as of now I have just kept these blank, right? So how to fill these? First one is resume file path. So we can select any of these resumes, right? So let's say as of now we will select this senior data scientist resume. So what we can do, just go to these three dots, click on this, and we can see here copy path. So we will click on this and our path for this particular file will be copied, and we will go here to paste this path, right? And this is the path for our file. And in a similar manner we will copy the path for this job description file. So job description file, yeah, so this is my data scientist job description file. It is in PDF format. We'll again copy this path and we can paste it here. So guys, as you can see, both these files are in PDF format now, right? But we could also have this file like data scientist resume. This is in docx file. Okay, we will later see how to execute this one. So guys, let's now understand this particular part of code, right? What it says, if resume file path, basically this one, dot ends with, which says if this particular thing ends with .pdf. As we can see, this is ending with .pdf, right? So this part of code will get executed. And guys, if this condition is false, then my cursor will come here to elif and it will check if this resume file path is ending with docx, then this part will get executed. And even if this is also false, let's say we are having any third format like say doc format, so this file will come here and this else will get executed and we will get this unsupported file format because we haven't created any function to handle .doc files, right? And for that reason we are having these three conditions. So if our file is in PDF format, then this part will get executed. If my file is in docx format, then this part will get executed. And if both these conditions are not true, then this part will get executed. It's as simple as that, guys. Now let's understand these two lines of code. What it says, basically it's calling the pre-processed text functions which we have created, right? And it is calling for both resume text and JD text. So what the argument we are passing, just focus on this first, and the second is similar to this. So we are now working on this resume file, right? So basically what we are doing is we are calling this pre-process function and we are passing this resume text as an argument, right? So let's just have a look at this pre-process function. So basically guys, we have already understood that this pre-process text function is pre-processing the text we are providing as an argument, right? So here we are doing nothing special, but we are just calling the function we have already created. And again similarly we are calling word cloud function which we have already created. So what this will do, this will create a word cloud for whatever the argument we are passing. So here now we are passing this JD text, right? So what is this JD text and resume text? Here also we have passed this resume text and JD text. These are nothing but the variables we have created right now in this if or else statement, right? And guys, these were calling these functions extract text from PDF or extract text from Word, right? So guys, as you can see, we have used all the functions we have created. The first one is this extract text from PDF, the second one is extract text from docx, the third function is pre-processed text, right? So in these we are just providing these resume file path and JD file path for first two functions, and for this pre-processed text function we are providing the variables which we have created right now. And similarly for this word cloud function also we are using these functions, right? And guys, at last we are using this similarity score, and for that we are using this calculate similarity function. So what was that calculate similarity function? Basically it was using this TFIDF vector and cosine similarity, if you remember, right? We have already explained this function to you. And guys, at last this was what this was returning. This was returning calculate similarity, and this print statement is doing nothing, but this will print this same thing which is written inside this string, and this will return us the similarity score. So it's finally time to run this code, this complete code, and what it will return these two word clouds, and it will return this print statement. So let's just run this using enter plus shift. And wow guys, you can see we are having these two word cloud. The first one is for JD text, means job description. So we will open this in another tab to see it very clearly. So we can see this is the word cloud for job description file we were having, right? And guys, this is the word cloud for the resume file we were having, right? So the main words you can see, like the most frequent word looks like data in this file also and in this file also. So we can see in job description the words are like data, machine learning, experience, problem, business, insert. These all are the main words we can see in job description file, and it looks quite obvious to having these words in job description of data scientist resume, right? So fine. And guys, here we can see the result is the similarity score between the resume and job description is this much, means we can say 22% or around 23% of a match is there between the resume we have provided, which was this data scientist resume, and we can see in job description file. So there is 23% of a match, right? So which is okay, fine. So guys, we have worked with this PDF file, right? So let's also check this docx file. So we will just copy this path of this docx resume and we will paste it here. So now let's again run this code, and guys, this time we can see this docx document, which is this data scientist document, this one is matching with job description by almost 29%, which is better than that previous one. So guys, this is how we can just select all these resumes one by one, and we can match these resumes with our job description. And guys, this is how the automated systems like ATS works. They matches the job descriptions with resumes, and they are selecting the top candidates like this, the resume which matches the most, right? And guys, we can adjust this similarity score threshold, or we can set a limit to determine whether a candidate is a good match for the job or is not a good match, right? So let's say we can, if we are setting the threshold to 25%, right? So this resume fits good as per the job description we have provided, and the last one where we were having a similarity score of around 23%, so that means that is below our threshold, means that is below 25%, so we can reject that resume. And guys, this is the motivation behind all the automated systems or all the automated tools recruiters are using these days. For an example, we are having ATS system, and many tools are there like this, right? So I hope you really enjoyed this session. So guys, let's end this session with a task. There is a very small task I'm giving you. You have to create, inside this main function, you have to create a loop, a for loop basically. And the function of that loop should be, it should take all the resume files. As you can see here, now we are having just 6 or 7 resumes with us, but in real time we can see the recruiters are getting thousands of resumes at a time, right? So we cannot copy the path again and again for each and every file and paste here. For that reason, you have to create a for loop which takes all the resumes of this folder, or we can also create a folder. So which takes all these resumes one by one, compares it with the job description, and the result in last should be how many. We can also set a threshold here, right? And we have to calculate this similarity score for all the resumes with the job description, and we want to select the best candidate, right? So this is the task you can do. And guys, doing this or using that for loop, we can make this system automated, right? So guys, I hope you have really enjoyed this NLP project session. And guys, you can comment down below and let us know the topic for which you want next video. Thanks for watching this video, and yes, don't forget to subscribe our channel for more such videos.